With the advent of computers and calculators and technology these days, many students struggle with doing math the old-fashioned way and actually figuring them out without just plugging them into a machine telling us the answer. One significant point of confusion for a lot of students is working with decimals, namely dividing decimals or dividing scientific notation. And so we're going to do a little shortcut video on how to get through these problems quickly and efficiently. So let's start with a more straightforward example. We'll start with 0.02 divided by we'll do a normal number to start with and not give you two decimals. Call it 40. All right, now when given these, first things first, you want to look at it and see that we're dividing a small number, 0.02, by a pretty big number, 40, so we know our answer is going to be pretty small. Always take a step back, figure out around what your answer is going to be first and foremost. Now that we've got that covered, let's get down to the nitty-gritty and talk about how we can do this division in our heads without doing any kind of long division or complicated math. So let's disregard our zeros, let's disregard our decimals, let's just focus on the numbers that matter most. We have a 2, we have a 4, we're dividing them. 2 divided by 4 of course is 1/2, and 1/2 is equal to 0.5. So let's start by just saying our number is going to have a 5 in it. In fact, we'll start with a 0.5, that's the number we have here. So now we know it's not actually 0.5, we don't have a 2 divided by 4, we've got some decimals and zeros, so let's add those in after the fact that we know there's a 5 in it. So let's start with the top. So now we pretended that this was not 0.02, we pretended that it was equal to just 2, thus the decimal would be just to the right of 2. So now let's just adjust it, let's bring it back to what it is in reality. So in order to bring it to its real position as 0.02, notice that we had to move the decimal 2 places to the left. So let's just do the exact same thing in our answer and move this decimal 1 2 places to the left, giving us this new number of 0.005. Now we're almost done to the answer, but we're not quite because we also have the bottom being slightly different. Remember, the top is the numerator, the bottom is the denominator, and we pretended that the denominator was equal to 4, not 40. So we need to adjust this to its actual position as well of being 40. Now we move the decimal to the right on the bottom, but remember, by definition, when we talk about fractions, the denominator is the inverse, right? It means that we're multiplying this thing by the inverse of 40, thus we have to move the decimal in the opposite direction. And so instead of moving it to the right, this is the inverse, it's backwards, we will move it to the left and actually move it one spot even further to the left because yes, there's only one 0 to deal with, thus we're left with our final answer of 0.0005. Alright, now since we're going to talk about scientific notation in a second here, let's just take a step back and actually talk about converting this to scientific notation as well. And so we've got, once again, a number 5, so we'll start with just saying this is 5 times 10 to the, now we just count our decimals. So it'll be 1, 2, 3, 4. So it'll be 5 times 10 to the -4th. -4 just means you need 4 decimals in the backwards direction, the smaller direction, the closer to 0 direction. That's 5 times 10 to the -4th as our answer. All right, let's do one more decimal divided by decimal example here, and then we'll move on to a little bit of scientific notation math. Let's get our numbers a little bit bigger. Let's say we've got 0.0016 divided by 0.0. We'll do 4. That should be fun. All right, so now before we get too deep into this, let's talk about one of the rules we do when we're dealing with zeros and not decimals. I know that people struggle often with decimals more than zeros. But if we were given a nice easy problem like, let's say we have 1,000 divided by 1,000, we wouldn't sit with our calculators and plug it in. We would just in our mind say, oh, well, those zeros cancel out, those zeros cancel out, those zeros cancel out. So we're left with just 1 divided by 1, which we all know is equal to 1. We can do the exact same thing when we talk about decimals. So looking here, we've got a couple zeros that we can actually just straight up cancel out. So if you want to, you could just get rid of those zeros and leave it right there. In fact, if you wanted to, you can even move your decimal all the way to right here, getting rid of that 0 as well, and moving your decimal to the right side right there. But for the sake of convenience, we're just going to cross out those zeros, and we'll go through the same tricks that we were going through a second ago. All right, so we've gotten rid of a couple zeros to save us a little bit of movement of our decimals here, and then we'll do our division. Alright, so same thing as before, we are going to look for the actual numbers, forget the zeros, forget the decimals. We've got 16 divided by 4 there, I won't circle the decimal for you. And we know 16 divided by 4 gives you a nice solid number 4. That's good and easy to work with. So then we just got to add in our decimals, same as before. So remember, we pretended this number was 16, not 0.016, and we had to move it 1, 2, 3 spaces over to get to the right answer there. So we'll do the same thing. Move this 1, 2, 3 spaces over to the left, giving us 0.004. And same thing as before, we pretended this number was 4, not 0.4. So then we need to move it 1 to the left. Remember, when you're dividing, it means inverse, thus we move it back 1 to the right, giving us our answer with a decimal point right there of 0.04 as our final answer. All right, now once again, doing a quick little conversion to scientific notation, because we're going to do that soon, we would say that's equal to 4 times 10 to the 1, 2, negative 2 position. All right, let's do one example of doing this with scientific notation before we call it quits. We'll do some number that's kind of fun to work with. I don't know, maybe we'll do, let's do 5 times 10 to the negative 8th, and we'll divide that by a big old number. Ooh, maybe we'll call this one 2 times 10 to the, let's make this third. So once again, we're dividing a very small number by a very big number. Thus, this is going to be an exceptionally small number that we get in terms of our results here. Now, you might look at this 5 divided by 2 and say, man, that looks like a fraction, and I don't like dealing with fractions. Well, it's not too bad of a fraction. 5 divided by 2 is just half of 5, thus it's 2.5. And so we won't deal with anything really fancy with that, because that's at least not a decimal place. It's a straightforward number. 2.5 is great. 2.5. People love saying 2.5. So we got 2.5 tens, then we will deal with our exponents here, 2.5 times 10 to the, and when we deal with our exponents, all we have to do is subtract them when we're dividing. So we're left with a negative 8 on top, and then we've got a 3 on bottom. Remember, you subtract exponents when you're dividing them, you add them when you're multiplying, so we're left with a negative 8 minus 3, which gives us to the negative 11th power. So 2.5 times 10 to the negative 11th. Good old-fashioned math without having to use a calculator. I'm just using pen and paper.